Yeah, everybody knows about them, right? Example of a normal equation is like, let's say there's a person named Jack, and Jack he has 4 apples and he ate 2 of them. So if Jack has 4 apples and ate 2 of them, how we represent this? Well, we would represent it as 4 minus 2 equals. Now we're trying to find how many apples Jack has now. So 4 minus 2 equals 2, which means Jack has 2 apples. But this is just a normal equation, right? But what if you say that Jack ate 2 apples, Jack ate 3 apples, and now he has 6 apples? How many apples did he have before? Now this is a bit different. We don't know how many apples Jack had. All we know is that he ate 3 apples and now he has 6 apples. Well, we can represent it using an equation, an algebraic equation. X minus 3 equals to 6. Equals to 6. So, now x minus 3 equals to 6. If we wanted to actually solve the equation, now there are 2 rules when solving an equation like this. Only 2 rules. Is that if you want to actually solve it, you have to make the unknown, which is x, to stand alone. And to do that, we have to move this anything with x to the other side. So since minus 3 is with x, we have to move it to the other side of the equal sign. So this will be x equals to 6 plus 3. And the second rule is that when you move something to the other side of the equal sign, its sign will be reversed. So minus 3 will change to plus 3. And note, you have to consider the number with the sign. So this is minus 3. So if I do something like this is going to be minus x, not just x. You have to group the sign and the thing together. So this will be, so if I put minus here, it will be minus x, not just x. So anyways, x equals 6 plus 3. Now that x is standing alone, we can finally solve the equation. Now, what is x? Well, 6 plus 3 is equal to 9, so x equals 9. Or that's our final answer. Now, Jack, he isn't exactly satisfied. Jack wants to see proof that x is actually 9. So, how? Well, since we know that x is 9, we can replace this x with 9. So, we can write 9 minus 3 equals to 6. Now, what is 9 minus 3? 6, of course. We can write 6 equals to 6, and 66 equals to 6 is true. That means our answer is correct, and Jack is finally satisfied. Now, Jack isn't that satisfied just yet. Jack wants us to solve another equation. But this time it's different. 6 minus y is equal to 4. So, what do we do now? Well, the first rule is that we have to make the unknown, which is minus y, to stand alone. So how do we do that? Well, we move whatever is with it to the other side, which is plus 6. So this will be minus y is equal to 4 minus 6. And all of us know that 4 minus 6. What is 4 minus 6? Well, 4 minus 6 is, of course, minus 2 but minus y minus 2. But now since both of these are minus, we can the minuses, they'll cancel each other out. So it will be y equals to 2. The two minuses are going to cancel each other out. So it's now going to be y equals to 2. And this is our final answer. And the same thing, if this was minus y equals to 2, minus y equals to 2 is the same thing as y equals to minus 2 and vice versa. They're the same thing. Now we have to check. So now substitute for y. So we write 6 minus 2 is equal to 4. And now 4 equals to 4. And since 4 equals to 4 is true, that means our answer is correct. And Jack is finally satisfied. So let us do one more example. And I'm going to write 2 minus y equals 2 minus z, because x is too overrated, equals to 4. So now, how do we solve this? Well, first we have to move this 2 to the other side to make z stand alone. So it is going to be minus z equal to 4 minus 2. So now we got this. Now that the z is standing alone, you can actually find out what z is. So to do that, we minus 4 by 2. So minus z is equal to 2. Now minus z is equal to 2. Now minus z is equal to 2 is also the same thing as z is equal to minus 2. So there goes so there is our answer. Z equals to minus 2. Let me put it in red. Z equals to minus 2. So now if you want to check if it is correct, then I'm going to replace z with minus 2. So you might think that is going to be 2 minus 2, right? 2 minus 2 is equal to 4. But that is not how you do it. It is not 2 minus 2. Instead, you have to think, when you're substituting it, you have to think of the sign and the unknown to be separate. So you think of z as a separate thing. When you're substituting it, you think of z as separate. You think of z as a separate thing and minus as a separate thing. So this would be 2 minus minus 2 is equal to 4. And of course, everybody knows that if there are two minuses, they'll combine together to make a plus. So it will be 2 plus 2 equals to 4. So now the answer is 4 equals to 4. Now since 4 equals to 4 is true, that means our answer is correct. Yeah, everybody knows about them, right? Example of a normal equation is like, let's say there's a person named Jack. And Jack has 4 apples and he ate 2 of them. So, if Jack has 4 apples and ate 2 of them, how will we represent this? Well, we would represent it as 4 minus 2 equals. Now, We're trying to find how many apples Jack has now. So 4 minus 2 equals 2, which means Jack has 2 apples. But this is just a normal equation, right? But what if you say that Jack ate 2 apples, Jack ate 3 apples, and now he has 6 apples? How many apples did he have before? Now, this is a bit different. We don't know how many apples Jack had,